After successfully installing the robot, now you need to set several things if you want to use it for the desired purposes.
In this chapter, we will learn about the robot setting and the environment setting for users by using a teaching pendant, TP. First of all, this is the main screen of TP. The TP has various settings for programming or moving the robot.
Starting from the left top, you will see the recording condition button. Using this button, you can set the condition for recording the results after the robot reaches a specific location. You can use the move command to move the robot to a specific location saved.
P stands for an interpolation used for movements.
There are three main interpolation methods.
P interpolation can be used to move the robot from a point to another point without restricting its posture. L interpolation can be used to restrict the robot's posture to a straight line. C interpolation can be used to restrict the robot's posture to movement along a circumference. S stands for the robot's movement speed. Units can be expressed in various ways such as %MMS and so on.
A stands for the robot's accuracy. The smaller it gets, the more likely it will move to the next location after reaching the teaching location. The bigger it gets, the more flexible curve will be drawn while the robot connects the teaching points. A can be set to a value in the range of 0 to 7.
T stands for the tool number attached to the robot.
A robot can be usually used with a tool. Depending on the characteristics, the robot movement needs to be changed. For this purpose, you can input tool data and set the robot and tool to move as one equipment. Below the recording condition button, you will see the Run Unit button. Each time you press the Run Unit button, it will be changed as follows. You can use the Run Unit to determine what is the unit of reading commands when running the robot commands in manual mode. Con means that the robot programming command is read in line by line. Step means that all the commands between the move commands are processed at once in the robot program. In other words, each time you run it, it is run as the unit of robot movement. N means that all the commands from the beginning to the end of robot program are run at once. The robot's current step and function are displayed as numbers at the top tab marked on the screen. In the next chapter, we will discuss details of how to record and program the robot locations. At the bottom of the Run Unit button, you will see the jog inching function. Press the jog inching button. You will see the green light turning on/off at the square at the left top of the letter. If the green lamp is lit, then the jog inching function is activated. You can use jog inching to make the robot move certain distance each time you press the button. If the jog inching function is deactivated, then the robot will continue to move while you press down the jog button.
At the center tab of the TP, you will see the coordinate button.
Each time you press the button for jog movement, the reference coordinate will be changed accordingly. In the axial coordinate, only one axis is moved at a time.
You can use the perpendicular coordinate to move the robot base in straight lines such as X, Y, or Z.
Tool coordinate provides the function to adjust the robot's coordinate in accordance with the direction of tilt for the tool. You can move the robot in the direction of tilt for the robot. User coordinate is used by user to set the random coordinate.
All you have to do is to select 3 points and set the direction of X-Y axis. Then the Z-axis will be set automatically.
The following is how to set the basic condition of robot.
At the right bottom tab of the TP main screen, click the Condition Setting menu. If you don't see the menu, then touch the Robot Program tab or press the ESC button to launch the top menu bar.
You can enter the Condition Setting menu to set the robot operation environment. There are various settings such as Robot's Auto Operation Cycle Setting, Step Forward Backward Speed Setting, User Coordinate Reference Setting, and so on. Even if you do not set it in default setting, there will be no problem in robot operation, but make sure to set it if required. At the left bottom of the Condition Setting menu, enter the Apply Condition menu.
In the Apply Condition Setting tab, you can set robot searches and built-in PLC.
For more details, see the Robot Control Manual. In the next chapter, we will discuss how to control and program the robot. The following is the user environment setting.
At the bottom of the TP main screen, press the System button to launch the User Environment Setting menu.
Go to the User Environment Setting tab. The following screen will be displayed. At the bottom, press the previous Next screen button to edit it.
In here, you can set TPU's controls such as Robot Posture Recording Type, Program Editing,
Functions, Collision Sensors, Coordinate Recording, and so on. In this chapter, we will learn how to set the additional axis. Assuming that the robot is successfully installed and the additional axis motors, cables, and controllers are connected, let's learn how to set the additional axis in TP. If the additional axes are already set, then there is no need to set them again. First of all, to set the additional axes, enter the engineering code.
In the TP, press the R button and enter 314. Once you enter engineering mode, you will see the alphabet E displayed in red on the top right of the TP.
The setting is applicable to reset of robot mechanics. So, if the additional axes are already set, then make sure not to change the settings.
On the TP main screen, press the System button to launch the Initialization menu.
Press the Initialization menu and move to the Robot Type Selection menu. Select the current robot weight and select the correct model. Enter the number of additional axes for the robot. By default, it is set to 0. After selecting the robot installation plane, press Finish. When the button appears, click Yes to move to the Additional Axis Parameter Setting menu. There are various types of additional axes. Depending on how the additional axes are set, you must select accurate specs. The following is the main types of additional axes. Baser refers to the additional axis such as driving axis installed at the bottom of robot. General is selected when carriage is used. Servo gun refers to the welding gun on the robot tool side. Positioner refers to additional axis that is far away from the robot, but that requires synchronized movement with the robot. Jig can be used to set the locations of additional axes in various ways. It can be mounted in the robot's exterior or tool. Axial configuration is used to set the direction of movement for the additional axis. Set the soft limits to restrict the limits of deceleration rate and additional movement. Also for amp and motors, find and select the accurate specs of controller and additional axis. Once the additional axes are set, you must reboot the controller to apply settings. This chapter will show you how to set the tool data. As discussed earlier, in order to make sure that the robot and the tool operate as one, accurate tool data is needed. Each tool has a different size, angle, weight, and so on. Using various methods, you can set the tool data. Actual work performed by the robot is not the tip of robot arm, but it is the center of the tool tip or specific location.
The location is called the TCP, Tool Center Point. For the TCP setting, you must enter the accurate tool data here. To set the TCP, first make sure to notify the robot of the location and angle of tool tip. Once the TCP is set accurately, the robot movement will be controlled with respect to the tool tip. You can set the tool data by pressing the System button in the TP main screen and moving to the Robot Parameter menu.
Select the Tool Data menu. You can enter the Tool Data menu to see the following screen.
You can set a total of 32 tools, ranged from T0 to T31.
You can enter number, weight, angle, length, inertia, center, and so on. Data can be adjusted by specifying the diagram values or measurement values. If there is no diagram or measurement value, you can use the tool calibration function to set them. Before using this method,
you must make sure that the tool TCP setting is clearly explained, and you also need a jig with a sharp tip.
Click the Program button at the top to create a program that you will not use. In this case, we will use 4001. Check that the current robot program number is 4001. On this program, we will record a total of 6 locations.
Put the location to be recorded with the tool TCP in accordance with the tip of the fixed as shown in the figure.
Move the robot and rotate it to various locations.
Put the tool TCP in the same location as the tip of jig and record a total of 6 locations. Press the record button at the control button below the TP to save the current location.
As shown in the following, a total of 6 locations are recorded.
On the TP main screen, press the System button to move to the Auto Calibration menu.
You will see the Tool Home Length Optimization menu. Select the menu and enter 4001, which is the program number recorded. Also enter the tool number and the step location error limit.
Once inputs are completed, press Run to ask the robot to automatically calculate the tool TCP value.
Now, we will learn about the control parameter setting function. Control parameters can be used to set various signals, functions, or external device interfaces, and so on. First, let's learn about the control environment setting.
On the TP main screen, press the System button to enter the control parameter menu.
You can see the control environment setting menu at the top. In here, you can change the operational setting of the robot controller's internal system. You can set the robot's signal output timing, power saving and output methods, and so on.
At the bottom of TP, press the previous next screen button to move between pages.
Before setting the control parameter, let's go over the robot signal system briefly. Your robot has various signals. There are virtual signals inside the robot and signals through relays where actual voltage outputs are generated. Let's find out about the 3 main signals. First, let's cover the die-do signals existing inside the robot only. It is composed of a single bit. You can control it using the robot program or ladder. The next one is called the field bus signal. If the robot is connected through industrial standard communication with external devices, actual signals are assigned as the field bus signals. The field bus signal outputted from the robot will be sent to external devices. The next one is the node signal. If it is connected to the outside through specific communications such as DeviceNet, actual signals are assigned here. Just like the field bus signals, the output signals from the robot are sent to external devices. Let's learn how to express the robot signal. The robot's internal signal, the I-do signal, is expressed as a simple now. At the beginning of field bus signal, a field bus area number is added and a period is added after that. In case of a node signal, add a period at the beginning of it and then an node number and another period after that. After inputting a signal, press Enter. Alphabets will be automatically added and it will be converted into a signal name. Let's set the input signals by using the signals.
In the TP main screen, press the System button to enter the Input-Output Signal Setting menu for the control parameter.
Once you enter the input signal setting menu, you can set the input signals received by the robot from the outside. Use it to issue a specific command such as start, reset, or stop the robot from the outside without using a hand. You can input signals corresponding to each function and assign them accordingly. For example, if it is connected to an external device via field bus signals,
then you can use the FB signal to control the function.
The same signal cannot be used repeatedly. You can also move between pages by pressing the previous next screen button. Just like the input signal setting, you can set the output signals. Output signal is used to display the robot's current status to the external device. Likewise, using the signal suitable for the currently connected communication method, you can display the current status. Also, it can help you to interpret the command by examining the robot's status displayed by the robot. You can also move to the output signal setting screen by pressing the previous next screen button. Finally, let's learn how to set the robot ready condition. The robot ready condition indicates that the robot is ready for operation with remote signals, not by hands of a human. The robot ready condition can be changed, and if all the conditions are met, Then the robot ready OK signal set and the output signal setting will be outputted. Besides, there are various settings. For more details, see the i5 Robot Control Manual provided by Hyundai Robotics. Thanks for your time.